So in today's class, let us look into an operation called sum modulo 1 and lemma related to this operation. And using this operation and lemma, we are actually going to construct a non-measurable set. Okay, so we measurable sets in the definition endaanennu kandu. So in this section, we are going to now look at the non-measurable set. So we will be constructing this non-measurable set. So for that, we will use this operation and we will use this lemma. Okay. Let us now define an operation called sum modulo 1, and this is the notation for the operation. Okay. Now the sum modulo 1 operation is defined by so for xy belongs to close 0 open 1. So we define sum modulo 1 to be, so this will have the value x plus y if x plus y is less than 1, and this will be x plus y minus 1 if x plus y is greater than or equal to 1. So this is the value of the operation sum modulo 1, and this operation sum modulo 1 is a binary operation on closed interval 0 open 1. This is called sum modulo 1. Okay. So you can see that if you take any x and y belonging to close 0 open 1, this value x plus y less than 1 ആണെങ്കിൽ that will be in this interval, and അതുപോലെ x plus y greater than or equal to 1 ആണെങ്കിൽ the value will be x plus y minus 1. So you can see that the value always belong to, so if I take the sum modulo 1 of two values, okay, അപ്പോൾ x ഉം y ഉം രണ്ട് values എടുത്തു കഴിഞ്ഞാൽ x sum modulo y will again belong to the closed interval 0 1. So if you take any xy belonging to closed 0 open 1, that again belongs to closed 0 open 1. So therefore it is a binary operation on closed 0 open 1, and it has further properties. Further we can show that this is an abelian group, that the closed 0 open 1 is an abelian group under sum modulo 1. So let us look at how this operation works. So if you take x sum modulo y, that will be equal to x plus y, then x plus y less than 1, and that will be x plus y minus 1 when x plus y greater than or equal to 1. Now this can be written as y plus x, where y plus x greater than less than 1. Just so x and y in തിരിച്ചെഴുതുമ്പോൾ നമുക്ക് so we will be getting y plus x minus 1, y plus x greater than or equal to 1. So this is same as y sum modulo 1 x. So x and sum modulo y will be equal to y sum modulo x. So therefore the operation is commutative, and similarly commutative nammal prove cheytha pole similarly the operation is associative. So if you rearrange again, you can show that it is associative. Any other when you take 0, so 0 belongs to close 0 open 1, and if you take x sum modulo 0, x belongs to 0 1, and when you take x plus 0 in the value x ആയിരിക്കും, so that is less than 1. So this means that 0 is the identity element. So this is true for all x belongs to 0 1. So therefore 0 is the identity element. So it has an identity element and അതുപോലെ when you take 0 plus 0 sum modulo 0 എടുക്കുമ്പോൾ again that will be equal to x plus y എടുക്കുമ്പോൾ x plus y will be less than 1, so the value will be equal to x plus y. So this is equal to 0. So the inverse of 0 under sum modulo 1 is again 0, and അതുപോലെ if x is belonging to close 0 open 1, then if you take 1 minus x also belongs to close 0 open 1. So x 0 1 ഇലുള്ള element ആണെങ്കിൽ again 1 minus x will also belong to 0 1, and if you take x plus 1 minus x plus 1 minus x ന്റെ value എടുക്കുമ്പോൾ നമുക്ക് 1 ആയിരിക്കും കിട്ടുന്നത്. So x sum modulo 1 minus x will be 1 ആകുമ്പോൾ so x plus y will be equal to x plus y minus 1 when x plus y is greater than or equal to 1. Okay, അപ്പോൾ ഇവിടെ നമ്മൾ x plus y എടുക്കുമ്പോൾ 1 ആണ് നമുക്ക് കിട്ടുന്നത്. So this value is going to be equal to x plus 1 minus x minus 1 വരും. So the value will be 0. അപ്പോൾ x sum modulo 1 minus x എടുക്കുമ്പോൾ നമുക്ക് identity element കിട്ടും. So that means 1 minus x will be the inverse. So 1 minus x is the inverse of x under sum modulo 1. So identity element exist ചെയ്യും, inverse exist ചെയ്യും, അതുപോലെ commutative ആണ്, associative ആണ്, അതുപോലെ it will be closed. അതായത് if x and y belongs to close 0 open 1, then x sum modulo 1 again belongs to the interval. A binary operation ആണ് നമ്മൾ ആദ്യം കണ്ടു. So therefore we can conclude that this interval close 0 open 1 is a, so it is an abelian group under sum modulo 1. So it will be an abelian group under sum modulo 1. ഇനി അതുപോലെ തന്നെ so if let me take E to be a subset of close 0 open 1, and let y belongs to close 0 open 1, and we define E plus y to be, so E plus y means that will be so E ഇലുള്ള എല്ലാ x ഉം എടുക്കുക. So if you have a set E which is subset of 0 1 and y belongs to 0 1, then E sum modulo 1 is defined to be x sum modulo 1 y, where x belongs to. So that is how we define the set E sum modulo 1 y. Now let us look at a lemma. So ഈ lemma ഉപയോഗിച്ചാണ് നമ്മൾ നോൺ മെഷറബിൾ സെറ്റ് construct ചെയ്യാൻ പോകും. So see this lemma. Let E be a subset of close 0 open 1, and let E be a measurable set. Then for each y belongs to close 0 open 1, the set E plus y is measurable. So we have defined what is the set E plus y. So we can actually show that E plus y is measurable, and m of E sum modulo y will be equal to m E. So let us prove this result, and using this we will construct a non-measurable set. Okay. Now for the proof, അപ്പോൾ E എന്ന് പറയുന്നത്, so let me take close 0 open 1. So E is some subset of the interval 0 1. Okay. ഇനി let 1 minus y be any value which is lying inside this set. അപ്പോൾ നമുക്ക് E നെ, so E can be expressed as the union of these two sets. So ഇങ്ങനെ ഒരു സെറ്റ് നമുക്ക് കൺസ്ട്രക്ട് ചെയ്യാം. ഈ പോയിന്റ് തുടങ്ങി 1 മൈനസ് വൈ വരെ, അതുപോലെ 1 മൈനസ് വൈ തുടങ്ങി ഈ പോയിന്റ് വരെ. So let us define E to be the union of these two sets. Okay. So E can be expressed as disjoint union of sets E1 and E2. Sorry, E. Okay. So define E1 to be E intersection. So take close 0 to 1 minus y, and take E2 to be E intersection close 1 minus y to 1. So let us take these two sets. So close 0, 1 down 1 minus y. So this is the set E. So E intersection close 0 to 1 minus y, that will be E1. E1, then E intersection 1 minus y to 1. So this is going to be E2. ഇനി നമ്മൾ E1 ഉം E2 ഉം നോക്കിയാൽ we are given that E is measurable. E measurable ആണ്. ഇനി നമുക്കറിയാം ഇത് intervals ആണ്. ഇത് രണ്ടും intervals ആണ്. Intervals എപ്പോഴും measurable ആയിരിക്കും. Now if you have two measurable sets, their intersection is again measurable. So here E1 and E2 are measurable. So ഇത് measurable ആയിരിക്കും. So call this as equation 1. And again ഈ രണ്ട് intervals 0 to 1 minus y and 1 minus y to 1 are disjoint. So ഇത് രണ്ടും disjoint ആയതുകൊണ്ട് E1 ഉം E2 disjoint ആയിരിക്കും. So since these are disjoint, so E1 and E2 are disjoint, and when you take E1 union E2, so E1 union E2 will be E intersection 0 to 1 minus y union E intersection 1 minus y to 1. So that will be equal to E intersection 0 to 1 minus y union 1 minus y to 1. So that will be E intersection. ഇതിന്റെ യൂണിയൻ എടുക്കുമ്പോൾ നമുക്ക് closed 0 open 1 ആയിരിക്കും വരുന്നത്. Now E intersection close 0 open 1 will be equal to E. അപ്പോൾ E can be written as the union of two disjoint sets E1 and E2. ഇനി നമ്മൾ എമ്മിന്റെ പ്രോപ്പർട്ടി കണ്ടു, M additive ആണ്. So if E1 and E2 are disjoint, then M of E will be equal to M of E1 plus M of E2. So disjoint ആണെങ്കിൽ we have seen this property for M. So call this as, so call that as the second equation. So this is equation 2. So M of E will be M of E1 plus M of E2. ഇനി അതുപോലെ when you take E1 plus Y, that will be equal to E1 plus Y. അപ്പോൾ Y എന്ന് പറയുന്നത് 0യ്ക്കും 1നും ഇടയ്ക്കുള്ള എലമെന്റ് ആണ്. So if X belongs to E1, then X is belonging to E1 ആണെങ്കിൽ X will be between 0 and 1 minus Y. So if X belongs to 0, 1 minus Y, X will be less than 1 minus Y. So that implies X plus Y is less than 1. Since X plus Y is less than 1, അപ്പോൾ X plus X sum modulo Y, നമ്മൾ sum എടുക്കുമ്പോൾ X plus Y less than 1 ആണ്. So that will be value will be equal to X plus Y. So therefore E1 sum modulo Y will be equal to E1